Define coulomb. Coulomb is a unit. So to define a unit, we also use unit. So 1 coulomb of charge flows through a point if a current of 1 ampere passes for 1 second. So this is one way of explaining this. For a short version, you can also do this. 1 coulomb equals to 1 ampere multiplied by 1 second. Okay, but both are equally good. Two vertical metal plates in a vacuum have separation of 4 centimeter. Potential difference of this volt is applied between the plates, shows a side view of the arrangement. A smoke particle is in the uniform electric field between the plates. The particle has a weight of this many newtons and these many coulombs of charge. Show that the electric force acting on the particle is this. So to show this force, first we need to calculate electric field strength and then use that electric field strength to calculate force. But there is a direct method as well. As we know, electric field strength is force divided by charge, and electric field strength is also potential difference divided by distance. So that means force over charge is equal to potential difference over distance. So force will be potential difference multiplied by charge divided by d. Potential difference was 140, no, 200. 200. Charge on the particle is 8 into 10 to the power minus 19. The negative sign is not important over here because we are looking for the magnitude of the force. So the negative just will be showing that the force acting on the particle is opposite to the direction of electric field divided by distance. What is the distance between the parallel plates? 4 centimeter. Now it is 4 into 10 to the power minus 2. Now 10 to the power minus 15. Okay, hence shown. I hope you are side by side checking my calculations. Good. On figure 5.1, draw label arrow to show the direction of the two forces acting on the smoke particle. Now, one of the force will be electric force. This one. Because there is a negative charge, so it will be pulled towards the positive plate opposite to the electric field, and the weight will be acting this way. Okay. Draw labeled arrows to show the direction of the two forces acting on the smoke particles. Now, resultant force acting on the particle is F. Determine the magnitude of F. Electric forces, as we have calculated in the previous part, it is 4.0 into 10 to the power minus 15 Newton. Vertical force will be, weight will be mg. Mass of the particle, I guess, was given. No, directly weight is given. 3.9 into 10 to the power minus 15. We don't have to use W equals to mg here. It is 3.9 into 10 to the power minus 15. So if there is one force acting this way and other force acting this way at 90-degree angle to one another, I am just taking 10 to the power minus 15 out of the equation, because whatever I will calculate, 10 to the power minus 15 will appear with the final answer. Okay, just ignore that for a while, for a moment. Now, this sideways force is 3.9, sorry, my bad, it is 4.0 into 10 to the power minus 19, 15, and downward force is 3.9 into 10 to the power minus 15. The resultant force will be from here to here. And I hope you can see that we can find out resultant by using Pythagoras theorem. So resultant will be 4.0 square plus 3.9 square root, at whatever answer you get, multiply by 10 to the power minus 15. So let's bring the calculator on. 3.9 square plus 16 square root 5.586. So 5.59 or 5.6 into 10 to the power minus 15 Newton. Okay, now moving on to the next part, the range f of the angle of f to the horizontal. Actually, he is calling this force f. So should we? He's asking for the angle from the horizontal, this angle. So angle will be tan inverse of 3.9 divided by 4.0. Again, I don't feel important to write that 10 to the power minus 15 with both of them, because it will get cancelled. So theta will be tan inverse of 3.9 over 4.1. So 3.9 divided by 4, 44.3. Now it is up to you. You want to give answer 44, it is okay. 44.3 is also very good. Now, the electric field B is switched on at time this when the particle is at a horizontal displacement this centimeter from the left hand plate. The horizontal velocity of the particle is 0. The particle is then moved by the electric field until it hits the plate at t equals this. Sketch the variation of this the horizontal displacement S of the particle. hits at t equal to. So what was the total distance between the plates? 4 centimeter. So at t equal to 0, it was at 4. It was at 2. At t equals, this is the point. So this is where it is supposed to be. Now tell me, do you think when force will be applied, object will move or the particle will move toward the positive plate with a constant speed or constant acceleration? If there is a constant force acting on it, remember it cannot move with a constant speed. So the horizontally, it will be moving with an increasing speed, and we are plotting a distance time graph for something which is having an increasing speed. What type of graph we should draw for something that has speed which is increasing? So the graph should be something like this. A graph with increasing gradient. Okay.